sound audible? Check one straight.
It's good. Okay. Don't mute. Don't ever mute. I think it should be okay. Like since I'm already doing that, and just in case. Yeah. Should I also like I'm only gonna place the question and then take a note somewhere. So I think it shouldn't be that. Oh, maybe Lasu. Lasu has it. He likes it. You can just plug it. I don't have the Type-C. Oh, you don't have Type-C. Yeah, just go back. Begini askar mı kadar bir sahnesi. Yun na yung mas kami siya.
Yeah.
Yeah.
Yes.
It's supposed to be blinking, right? It's not. Mine is working. It's serious. Getting numbers like just back up, and like that. It's in the discuss.
የባለፈው አለች ከሰላሳ ሊሆን ነው
Introductions. Okay, you should? Yes.
Mic check, 1, 2, 3. Audible? Okay. Welcome everyone to the ACL finals. For people whose first time this is a competition organized by HSV in order to boost the morale of students and also encourage the best problem solvers. HSV is an academy focused on training students for competitive programming and also for interview preparation for top tech companies. And this is one of our ways of encouraging students and identifying the best potential that we can find. And right before me is one of the finalists preparing for this, Birehan, and we'll be conducting his interview. And everyone who's interested, they can join the live stream that's happening on YouTube to follow through with the code, the question, and the follow through. And thank you for taking your time. And we can jump straight into the interview. Are you ready?
Yes. I'm Birehan, a fifth-year software engineering student at AIT, at University Institute of Technology. And I'm part of ACL for about a year now, and yeah, that's all about me.
In that case, if you can see the share pad, and the meeting is good, right? We have the share pad on. Okay, we have the share pad on, and so I think I can put in the question.
Okay, so give me a couple of minutes to read and understand the question, and I'll be back to you. Okay, so the question says you're given an array of nums, which is consisting of unique positive integers and an integer k. And in one operation, you can remove element from the first or the last of the array, which means we're given a num, and then I can take the first or the last on each iteration and add it into my collection, and I have a collection. And on the next step, what do I want to, as like the minimum number of operations to collect an array which is containing numbers starting from 1 up to k. Is that the question?
Yes, exactly.
Okay. So let's try to go over with the first example. So we're given an array of 3, 1, 5, 4, 2, and an integer k2. So what can we do is like we have 3 or we have 2. The numbers that I want right now is 3 or 2. One and 2. What I want is 1 and 2. And then if I take these 2, I can take it, and that's a way to go. And then on the next iteration, I can come from the left 2 steps and then get 1. Since I'm leading only 1 and 2, it's going to take 3 steps to get 1 and 2. And on the next step also, I have 5, 3, 2, 1, and k is 3. So I need 1 up to 3, and then taking the last 3 elements, it's going to give me 1 to 3, which is 3 steps. So is there always an answer? It's guaranteed to find an answer.
Yes, that's true.
Okay, so if that's the case, can I ask for the limitation constraints?
Okay, let me paste them down below.
Okay, so our length can be in worst case 10 to the power of 5. So what's the brute force approach in here is like, what we can do is like, it's always about branching. So I can take the leftmost element, I can take the left or the right. If it is equal, if it is in the range of number that I wanted, I mean, let's say I will have a left and a right, which is from 0 and the last element, which is 4. So I have 2 options right now, right? So I can branch, like if one of the parts, if the left or the right is equals, if it's a number in a range that I wanted, I'm just gonna shift to the next and shrink my window. And if that's not the case, I have 2 options, right? I can come from the left or I can come from the right. And then at the end, from the 2 branches, I can return the minimum one. So it's gonna be worse because at each step I can have to the power of n branching, because like in every stage, if it's not similar, I'm gonna branch shrinking from the left or shrinking from the right and try to find an answer.
Okay, yeah.
So does that works?
I think that makes sense as a brute force approach.
Okay, so give me a couple of minutes to think of a little bit of an optimal way, and I'll be back.
Sure thing, take your time. just to check back in, can
Okay.
you walk me through how it's going?
Okay. So what I'm thinking is like to find. I'm guaranteed that the numbers are unique. So there is no duplicate or there is no two solution. It's going to be only one solution. So meaning wise, I want k numbers. So what I'm going to do right now is like I'm going to pair the. What I was thinking is pairing the numbers with their indexes, which is the numbers, all the numbers, and then their indexes. And then after pairing them, I'm going to sort them, right? And then after sorting them, I'm guaranteed that the first k elements are the elements that I want right now. So if that's the case, now I want to find until which leftmost point and until rightmost point that I have to count from the left and from the right. So let's try to go over the first example. So
I think concept-wise, that makes sense. If you want some time to refine it, you can. If you want to go over example, you can.
I will have to refine it a little bit and yeah.
Take your time.
Okay.
Okay. If you can walk us through how you've come so far.
Okay, so after pairing and sorting them, so I couldn't come up with a better way, but let's try to go over it. And if you find something along the way, we'll try to see. Okay, so I only need one and two in this iteration,
Yeah.
and which means I'm going to have one in here at an index 1, and I'm going to have 2 in here at an index 0, 1, 2, 3, 4, right? So what's a better position to get that number, from the left or from the right? So that's actually what the question wants for me, but I haven't come up with a solution to how to optimize it, because I have to traverse through from the points that I get, like, so, okay, good. I'll be back, so give me a minute.
But I think it's on the right track. We can think about the choices that we're going to make from the left or from the right, and we can see if we can optimize that, perhaps.
Okay, so always I can pick, like, this is my numbers that I want, right? So let's say I have this number, which is at 1, 1. So what's a better way to get this number? Is it a better way to get it from the leftmost or from the rightmost, right? So, okay, here comes an idea. So what if I sorted the extract the numbers first initially with the index, and then second with the numbers. If that's the case, and it's going to work out. So it's going to be something like this, right? 4 and 2. Now, I'm going to have the index paired with the value and the index paired with the value. So the smallest index is going to come first, right? So when I have the smallest index, my boundary is going to be always from the left and the right. So that smallest index point, I have to come to that point, either from the left. Yes, that's the possible scenario. I can come from the left or from that reverse of it. So what's the best way? If it is from the left, I will move my actual left to that point, and for the next iteration, that's going to be updated. So let's try to generate some other case. Let's make this, let's make this 3. So in such a case, what we're going to have is like, we're going to have initially in here, at 0 index, we're going to have 3 value, right? And at 1 index, 1, and something like this. So in the first step, I have the leftmost element that I have to include. So I can include it coming from the left, from the current left that I'm at in, which is 0. So I'm going to move to that point. Okay, I get that point. So the next step is to 1, right? So moving to the next step, it's like 1, 1. So 1, 1 is it better to get it from 0 or 4? It's better to get it from 0. So now when I move to the next step, I'm going to change my left to 1, which is the new left. So it's going to be, my new left is going to be 1. And then on the next iteration, I have an index of 4, right? So what's the best way to get it? From the last for 4 or from the left, it's going to be the last. So update the right. And that's the solution. It's of n time. Am I on the right track?
I do have a question about, so when we're checking whether to move from the left or to the right, when
Yes.
we're going one element at a time, are we going from the one that has the smallest index to the largest index? Or
Yes. I'm going from the smallest index to the largest index.
Is there a case where maybe we can look at the second example? Maybe that can make it clear.
Okay. So what do we have in here? I'm going to need only the 3 numbers, right? So what's my smallest index, which is 1 of 3, right? And then the next value, which is 2, 2 of 2, and 3 of 1, right? These are all the 3 possibilities, numbers. So I'm going to start from the smallest index. I have 1, 2, 3, right? So what's my left, comma right, is going to be like 0, and what's the length? It's 4, right? So what I'm trying to check is like, this is near to the left or to the right? It's close to the, okay, it's close to the left, not the right. Okay. So what I can do about it is like, so if that's the case, like,
I think it makes sense that you're greedily trying to get like whichever one is nearest, but the starting point, should we have it with the smallest index or the one nearest to the endpoints?
okay, yeah, that makes sense. So, okay, so if that's the case, can I, okay, if that's the case, let's proceed with this like this. So when I'm starting like this, so what's the nearest point for 0 and 4? Is that the case, right?
Yeah. Which number is closest to the boundaries?
To the boundaries. Okay, so it's going to be like, which is the last element, which is this one. So that's going to be closest. So when I take that closest value, the right is going to be updated and it's going to get to become a 3. So I'm going to take that out. So, and next step, what I'm going to check is the closest point to the left and right. My boundary is updated. So what's closest for 0 and 3? It's, I think, this, okay, this is not 4 actually. This was 3 and this gets to become 2. Now this is nearest. So we can use a binary search kind of a thing, or, right?
You can continue, yeah.
So if you can, like, if you sort the values and then get the list of their positions, and I'm going to have a left and a right position. So on every iteration, what I'm going to do is like, I'm going to find, no, that's not the way.
No, I think it's good. Go on.
Okay, so if that's the way, I'm gonna like binary search. So I have the left and right boundary. So on each step, what I'm trying to find is like what's the nearest point to that boundary. So on each time, so when I do that operation, I'm going to shrink my boundary. Optimally, what I want to do is like the gap between left, right to maximize. I want to maximize the gap between left and right?
Yeah.
So every time, so what's the nearest point, and I will come to that next point. So
Just quick follow-up. Do we need binary search in that case? For what we want?
Okay, so if we don't need a binary search, okay, so let's try to go over this example again and let's try to see what I've missed. Okay, so what do we have in here? 3 and 1. So in such a scenario, I have left and right, and I think I've already sorted the
By indices, yeah.
by indices. I have already sorted by indices, and then what I'm going to do is the first point closest to the left or the right point closest to the left. So that I can shrink my pointers, and then I think that works. Okay, so are we on the right track? Should I proceed?
Yeah, so far that makes sense. Maybe we can quickly cover time and space, and if you're comfortable, we can go to coding.
Okay, so the time is going to be like of n time, of n log n time, because we're going to be sorting the values, and then the space complexity is going to be somehow, we're going to use the list, so it's going to be of n.
That's fair, that's fair.
Okay, so can you give me the base function, or should I write it up?
I think you can write it on your own.
Okay, that's much better. Okay, so what's the question? Get mean operation. So we're going to be given nums, right? So
And also kill.
And also,
okay. So initially, we're going to have like nums paired. So let's call it paired, and we're going to have a list of. Okay, actually, I want to first extract the values, and then afterwards I'm going to reverse the x and y. So what I want is initially nums at I, comma I, for I in range lane of nums. So I have taken out every paired, and I want to sort it now. So it's going to be sorted based on the first number. So now I want to take the first k numbers. So let's call them k nums, and it's going to be paired until the index of k. So after extracting them, I want to update k nums into a reversing way, because now I want to do something else. So that's going to be like index, comma num, for num, comma index in k-nums, right? So so what do I do in here? Index, comma num, for num, comma index in k-nums, and this has to be equals to, and k-nums dot sort. So now I have sorted them with the index. So now I have two things to play with, right? So the first one is from this paired left and right. So left and right is going to be 0, and the rightmost, what's the rightmost is going to be like lane of nums -1. So I have this left and right, and also I need another left and right for the k, right? Because to go over the left and the rightmost of the k, right? K-nums, because I extracted the k-nums, right? So if this k is shorter, but the left and the right is longer than that.
Oh, I see.
So we're not iterating over the k-nums?
Yes, we're going from the k-nums.
Oh, yeah, fair. That makes sense.
Right, but
makes sense.
Okay. So what do I have to do right now is like let's call it this k left, and k right, which is going to be like 0 comma lane of. Actually, I can make this a k minus 1. Okay. So what I want to do is like I want to get all the k numbers, right? So it's going to be while left less than or equal to actually k left less than or equal to k right. So now I have two ways. So I will have to compute the left value with the actual left value at its distance, and also with the rightmost one. So let's call it left dist. So it's going to be something like, we can use an ABS for the time being. So I went to get this k left names, right? And then I have its index with its value, but actually, why do I need its value? I don't need it, right? So I can just take the indexes because it's not useful in any ways. So I can make this an underscore, and I'm just only taking the first pair. So what do I do now? I have the key names, and then at key names, I have the k left, right? So this is the leftmost index to the left, and its difference should be, which is like left with actual, the bigger left, and what's its distance, and right, this is going to be a little bit imitation of this. Okay, so let's make this right. Let's make this right. So I have the left and the right distance. So now I have to pick from which to come. So I've left this less right this. So now the distance of left is less, so I have to come from the left. So if I have to come from the left, my left has to be updated. So the bigger index left. So in here I can compute it at the end of the day. Okay, so when I'm coming from the leftmost to the current left, so it's going to be like the point that I want to go, which is the k-nums of left, this thing, right? Which is the next left point. And then what do I want to update is like, I want to come one step from k left. So k left plus equals 1. Else, I'm going to do the reverse of this. So the indentation is not right. Okay. So I'm going to have right in here. K right and K right. So right is going to be coming from the right end. At the end of the day, what I want to return is like, I have the maximum left and right possible point. So what I want to return is like, I have the lane of nums, right? So that's the total length minus the middle window that's left. So so it's gonna be like right minus left. So the bigger right minus left is like the window that I can save without coming up from the right to the left, and then I think this is the case. So let's try to go over it with the first example.
Yeah.
Okay.
Since we're running low on time,
Yes.
we can.
Okay. So can I assert? Can I assert run it? The question?
Yeah, we can.
Okay.
We can do that.
Okay, this should be, okay, I'm wanting, okay, if it was 2 numbers, that makes gonna be 3. So, line 44, okay. So is there anything am I missing, or
During the if else, maybe you can take a look here.
okay? So what if they are at equal point? Is that the case, or
Maybe in the else statement, perhaps. Like, what do we do if the right is more close
more close than what?
than the left? Like, what should our steps be? Maybe you can look into this.
Okay. So what I can do from here is like I can always okay. So
Not that. Not that. The next line, perhaps.
okay, when coming from the oh, you are right. My but let's see. It should have been, I just copied it and that's why it's causing a problem. Now I have an assertion error. It should have been 3. And but what's it's outputting?
Maybe remove this as well.
Okay. So we're getting only a 2. I think I have to do this -1.
Can
Is
you
that the
explain
case?
why?
Because it's like the boundaries.
Yeah.
So yes, it's giving me a 3. So let me just try to go over it for the second example. Okay, I have this thing, and I am expecting of 3. So let me. Okay. Oh, it's giving me a 4 while it shouldn't be a 4, right? Because it shouldn't be a 4. So should I have to go to whether k less than or equal to k, right? Because I want to take every number right. So I have a left and a right. So what if I can do in here something like operations, right? So I know my operations 0. So when I move from the current leftmost to that point, I know that my always my operation is going to be like I have this distance. So my operation is going to be that distance. Am I on the right track?
Let's see. We can. I think we can try it this way.
So operation is always the distance that I'm moving, right? Because they're gap. So, and this is going to be also in here. So this is going to be right test. And I'm going to return the operation. If that's the boundary thing is the case, let's try to see that. Okay.
I think in the interest of time, I think there's just a simple fix, operations.
Okay.
But I think in the interest of time, we can pause here and then we can take this into consideration as well, just because of the time constraints that we're under.
Okay. So can we? Okay, I think. Oh, it's not the case.
It's a small bug in the implementation. I think we can figure it out after. I think concept-wise, I think we're on the right track and everything makes sense so far. So yeah, I think it's all good.
Okay.
All right. Testing 1 2 3. No. Testing 1 2 3. This would be the voice that we'd be using for the interview. Is that audible?
If the sound is off, it's too cross. Assume is the PC picking up its own voice. Let's not know is that.
Because there is a lag to show up. Once it talks, it's gonna shout finish for you. That's gonna the equal high shit, high. Then.
I get the yes. So yeah,
This should be fine, man. I got it's okay. He said quality.
It's just a second thing.
Yeah.
Just.
ከዛ ሁለታችን ካሜራ Okay, welcome everyone to the second round of ACL finals. Now we're with Yohans, and I guess you can start by introducing yourself.
I'll go after you.
Okay, I haven't in the first one, so I'll join this one. My name is Brooke Salomon. I was a student at A2SV for the past 4 years, and now part-time lecturing and part-time assisting in basically education support. And I've had the pleasure of interviewing Johannes today, and I'm excited for what comes after.
Okay, thank you, Brooke. I'm Yohans. I was a member of Group 32 back then. Now, currently, I'm a head of education in the remote for Group 49. Yeah, thank you all.
Okay, with the formalities out of the way, if you're ready, we can paste the question in and get started.
Yes, I'm ready.
Okay, give me a second. Okay, can you see the question?
Yes.
Give it a read and get back to me.
Okay, you are given an array names consisting of unique positive integers and an integer k.
Quick adjustment. Can you turn on your mic and me turn off mine?
Okay. You are given an array of names consisting of unique positive integers and an integer k. In one operation, you can remove either the first or the last element in the array and add it to your collections. Return the minimum number of operations needed to collect elements 1, 2, until k. Okay, k is given. Now, operation, you can remove either the first or the last element of the array and add it to your collection, and it's asking to have the collections from 1 until k. And it's asking also for the minimum number of operations. Okay, so the order doesn't matter here.
Yes.
Okay, let's see the first example. I have to collect 1 and 2 in this case. So this one in one operation, I got 2, and this operation is like a cost. And in the third operation, I'm getting 1. So I'll be collecting 1 and 2 in just 3 operations. Okay, remove 0, remove 1. Okay, this is getting this element, and by removing 4, it's getting the 2 operations. Okay, okay, it feels good. The second example, k is 3, so I have to collect 1, 2, 3. So these 3 operations will be fine, I guess.
Yep.
Because like there is no intruders. Like if there was an intruder like this one, it would have been a different case. No intruders, so just collect them from the back. I guess that's the logic. Okay, so one question I have is, are we guaranteed like all the elements like until 1 up to k are in this array?
Yeah, we're guaranteed that.
That's awesome. Okay, so we are removing from the last and from the front, from the box. So by removing this like from the last and front, there will be elements left in the array after popping them.
Yeah.
And with this element that is left in the inside, we want it to be like a big one.
Yeah,
obviously,
that makes
a
sense.
big one. And it doesn't. We don't want it to have any of elements in this section, which is basically all of them should be less than k. All of them should be greater than k. Of course, of course. Yeah, I mean, because it's guaranteed, it says also it's unique, you know, that's also a good thing to hear. So let's just find the maximum window. All of them are greater than k. Okay, so we remove this part. So we are like popping this and this. So these are giving us our collections. They are guaranteeing our collections. So if there was another element, k, it cannot be part of this the collection. So we are like including it to the window.
The window that yours clear up and down.
Yeah. So can there be like multiple such windows is my question. You know? Can there be a multiple of such windows? So element. So this might be the window, one possible window, which means like it doesn't contain any element that is less than k. It's and we might also find another window here.
Yeah. Just
So
for the clarity, can you replace the e's with numbers? Just so it's easier for everyone to follow.
yeah, so I mean like it will be harder to like
It could be smaller.
yeah. So let's say k is 3, 2, 3. I mean let me have all of them and like I can shuffle them. 7, 8. So can we have like separate windows? So let's say 3 is here and 2 is around here. So we have such window here, such window here.
Okay. This is 2, right?
This is 2. But clearly like this cannot be possible because this has to be removed. So one of them, either this one or this one is going to be chosen.
Yeah.
So in addition to being a largest, there is an additional criteria.
What would be the additional criteria?
Yeah, let me, I should be thinking that one. I mean, like you have 2 windows. Let's say this is like a large one, you know, and this is a smaller. This is a smaller one, and this, let's say this is a large one, like 121, and so like I'm getting this as a large one.
Yeah.
But you know, these 2 is disturbing. I will be like choosing this one, but it's actually it's fine. You know, all elements here are like getting eliminated. So I'm choosing this element, the one to be staying here. So yeah, I think that's fine.
Taking the largest.
Just take the largest. We have guaranteed that there is no element that should be in the collection. Everything is just inside the collection. That will be fine. So if there are multiples, just pick the large one, the biggest one.
Maybe you can walk us through the time complexity.
Okay, how do you find the largest one? We haven't talked about the details, the implementations. Okay, so it's going to be a sliding window thing. So I will just start one by having 2 pointers, and I will expand as long as the conditions are held, which means no element less than k, less than or equal to k.
Yeah.
And when I have an element that's going to be part of the collection, then this cannot be expanding anymore.
Yeah.
So I will just start over.
Makes sense.
I will just start over and do my sliding window. So the 2 pointers, I'll just like follow each other. There is no like repeating, visiting elements twice or anything. Every element will get its visit only once, maybe twice, and this means it's going to be of n.
That makes sense. Transfer time. How about space?
No additional space is going to be used. We are not doing anything. We are just iterating on the input. If the input is not considered, then it's going to be constant time.
Constant space, yeah.
Yeah, constant space, sorry.
Makes sense. If you're comfortable, we can go to implementation.
Yeah, I think it's fairly easy implementation, fair implementation. So let me call it mini operation. Get min ops, array, and k, right? So let me give like space here. Even this one, and like the idea is to get collection is going to be 1, 2, 100k. Okay, so I have a size. Chocolate level. Okay, I have to be louder. Is it fine now? Okay, so yeah, I have a left pointer that's going to be important for right in range of length of k. So it's a window, so I need 2 pointers. I will just make the left pointer here. and the right pointer will start at 0. Okay, so the first condition, if the current element is less than k, less than or equal to k, we need to do something. So if RA right is less than or equal to k, start over. So when we start over, we just put it here, like we are ignoring the current element, so left is going to be right plus 1. Okay. After, if not, we will just move on our right.
Okay, yeah.
So automatically right is just going on by itself. So we have our maximum window. Window initially, I'm not sure about that, should initially be 0. 0 size means we are like popping all the elements. So it makes sense to have maximum window as a 0. Okay, current window size. Current size. So it's going to be right minus left plus 1. So in this case, like if there is no window here, left is going to be here and right is going to be here. So this is going to be -1 plus 1, 0. If we don't have a window, you know, if it's consisting of an element less than k0. Okay, max. Let me call it max size. Size, max size. Okay. Yeah. So after ending the loop, we will have our maximum size. So the number of operations is going to be length, the total array minus maximum size. So this is going to be the one we are going to return. Any questions?
I think the explanation was good as we are going. Would you like to test it?
Here?
Yeah,
Yeah,
you
that would be
print out
nice.
the results.
That would be nice, yes. Okay. Let's have the first example. Like this. And this one. And print. Nums k. What did I do here? Len k. That's funny. It's saying 3, which is correct. We can also add our own examples. This is the second test case, which is also 3. Which is also 3. It feels good. Let's do a few things. Let's English k. In this case, 1, 2, 3, so it's going to be 3. It's going to be 3. Edge cases, I guess.
Yeah.
Edge cases. What would be the edge case? Okay, having k. Can I have the constraints? Sorry,
It's verbatim, but you can definitely get it. Let me paste it up in the comment section. So,
Yeah.
right, I guess here would be a good place.
K is at least 1. And this doesn't affect our solution. This is 10,000. That's fine. Yeah, 100,000, yes. So having k as 1, we are either popping here or popping from the away. So let's test this one. So I'm finding the largest one here. If it's here. It will be fine for k equals 1. For length is equals to 1. For like names having just one element there.
Maybe you could try that. It's a simple case.
You just run it.
Yeah, just run it, see what comes up.
Yeah. So names should be 1 and k is equals to 1. Just one operation, yes. Maybe this way. Still on. Still on. Yeah, I think it looks good.
That makes sense.
Uh-huh.
Is there anything else you'd like to polish? Like, since we have a follow-up also.
So do we have a follow-up?
Just in case we get there.
Okay.
Is there anything you want to clean up here? I think from my angle, this looks pretty good.
Okay.
In case you want.
Okay, that's fine.
That makes sense. The additional the follow-up is going to be, how about if these numbers are not guaranteed to be unique? We don't have to implement it. We can just think it through, and then if we have enough time, we can go and implement it.
Definitely. If they are not unique, the condition is still going to be the same. The window that's going to be largest shall not have any number less than k. Shall not have any less than k. That's going to be still the same. What's going to be changed? Okay. So when we find our window also, we'll be just going on and like we need to start over. That's also the same. We need to start over if because like this window shall not have any elements, so we should start over.
Are you sure about that? The window shall not have any elements less than k.
Oh yeah, yes, you are correct. Because the only thing that we need is just like having it in our collection. As long as we can have it in our collections, it doesn't matter whether it should have what do you call it, the numbers.
Yeah.
Okay, in that case, it can be so the window that's going to be removed, that should have all the numbers less than k, all of them.
Yeah.
So we need to have a hash map to track this.
That makes sense.
Definitely. Should have like a hash map that will make sure. So it's going to be still it should still need to be a sliding window. We need to expand in the minimum. And what I'm thinking is like to have this array, as an example. This is the array, right? So like we are like doing sliding window on the last part of this, because there are going to be repeated ones. So how do we do sliding window on this one? So one idea is like you can start, one way is like to duplicate. Like we have all these at first in our window. And as long as we have all the elements, we will be tracking it using a hash map, obviously. So as long as we have all the elements, we can narrow it. So here k is how much? 3, right? So in this case, we have all the 3, 1, 2, 3. So let's try to narrow it. So this is going to be the window. You can see it, right?
Yeah, I can see it from the screen. No worries.
Yeah, it's going to be the window. So now the condition is less. We don't have one element. So let's expand it. It's going to be this way. Now the condition is fulfilled. Let's narrow it. This is the current window. The condition is not fulfilled, so we need to expand it. This is going to be this case, right? I have merged the two arrays. This way we can wrap around the windows.
When we're deciding to expand, do we expand to the left or the right? Is that something we should be worried about?
We have currently it was like this. So when we expand, we'll be expanding like to the right, like this way.
Okay.
This means I have like pop it. It doesn't happen like this way. We are not like popping all the arrays and then additional ones. That will not happen because this is like the maximum we can get. So the next window is going to be this way. This means we have pop from the right, all of them, and a few from the right. Yeah. So this is also a valid window, like expanding and minimizing. Next is going to be this way, and lastly we can reach here, like narrowing one. and this is 3. This is the optimal one.
So is there a case where I guess my question would be, when would we be moving the right pointer, and then when would we be moving the left pointer?
Yes, so we have a left and right pointer. So if the conditions are valid, we narrow it. Narrowing means moving the left pointer.
Okay.
And if the conditions are not valid, which means we don't have all elements, we will be moving the right pointers. So moving the right pointers means in a conventional array. So we have this and this. So we are popping from this one. You know? So this is what's going to happen.
And when do we stop?
When do we stop? That's a good question. So finally, let's say it's going to be this way. So we are going to narrow it. Let's say for now, this is going to be this case. Still fine. It's going to be this way and this way. So this right, the left pointer shall not like move more than this, because this means we are not popping this. We should not pop, not pop. You know, there's no skipping of this element.
Yeah.
So we should stop whenever we are trying to move the left pointer from A.
Yeah, I think that makes sense. That's ideal. Is there anything that's on your mind that might be a concern?
I don't think so, but like keeping knowing whether the window fulfills the conditions, that can be tricky. So we have a hash map that will be registering all the elements there. So we need to keep count of them. So we need to delete from the hash map when there is 0 elements of that, and like increment it and stuff. So implementation wise might be tricky. Edge cases, I guess it's fine.
Okay, that does make sense on my end. We have about almost 9 minutes. Do you want to give it a shot at the implementation?
Yes,
Or?
definitely.
Okay.
Definitely.
You can write a new function.
Yeah, definitely. So not unique is going to be the new function. It mean not unique. Okay. I have array, I have k. That makes sense. So array should be, array plus array. Left 0 and right is going to be length of n minus 1 should register n. So max size looks good. Let's just a destruction. We need a hash map, so let's call it window map. So all elements from 1 to k, all of them as a 0. So let's say currently we don't have any elements unless for this window. So we should add all these elements to this window. So should I make it default? No. It would be, I should delete it from the window, so that I just check the length of the window. So deleting is going to be very important. Can you still delete from default, right?
Yeah.
Yeah, you can still delete from default. Okay. I have a default, so I will be having a count instead of just checking whether there is or not. So for val in array, so this is like all elements in array, or not array actually. Let's just run it. And why is the indentation a bit weird?
Yeah. I think it's fine. I don't think we'll be running this one since in the interest of time, but yeah, I want to see as far as it goes.
Okay, so we should add val. So val is going to be array. So we should increase val. Have count of all the elements now. Now let's slide the window. Okay, so left and right pointer, right? So we run until as long as the left pointer is like finishing all the array. So while left is less than or equals to less than n. I'm not sure about that. You can check it. Check it later. Okay, so right was here. So while we have our condition, which is length of map, should be while this length is like having all these elements, Okay. Here though, like we are thinking the condition is up here, like the condition is fulfilled at this point,
Okay.
So we have to register the result. Where is the result? Max size is the. So in this case, it's going to be minimum size. Main size. So initially, n is going to be the case. So minimum of. Minimum of size and right minus left plus 1. This is the window. This is the window. Okay. So as long as now we will be moving the left pointer. So we decrease the left value, array of left, by 1. And if it's 0, we don't want it on the hash map. So I guess it's pop. Oh, this is, let me have it left var instead.
That's fine.
Yes, it should be left var, yes. Left var, left var, left var. This is how we remove it. Like removing is going to be important because we are, using this length thing.
Yeah.
Okay, after we do that, we increment the left. So, like we should also take care of this thing. But like it's going to be taken care of at the second iteration. Like after doing this, we will be like incrementing the right pointer, and we should also add the right pointer here. So we have a new right, so we should add it to the hash map. It's going to be a bit tricky, like we can take care of it later. So right val array right, and what was the hash map? Green map. So right val incremented by 1. We are incrementing it, and like after that we are adding it to this one. So for sure the conditions are fulfilled here.
For sure.
But let's just add a condition, right?
Yeah,
Why not?
yeah,
Why not?
Yeah.
Why do we this? And let's do it also again here. But it will not be like, for sure here the condition is not fulfilled because we are like decrementing it. So, and also like here we are adding the right.
Yeah.
So I mean, like the easiest thing to do is like just add this condition here after moving the left. As long as inside the while loop, we just it doesn't hurt.
Yeah.
Now, like finally, we will return the main size. It's a bit messy.
Yeah, we have 1 or 2 minutes left, so I think we can call it. There may be a few implementation bugs here and there. I think conceptually, we're doing good. But yeah, I think in the interest of time, since we're just left with 2 minutes, we'll leave it at here. Thank you for going through the interview. This was a pleasure. And thanks for your time. Are any comments you want to say to the world before the interview ends?
I would expect a comment from Toli, maybe. A comment.
I think in that case, no comments. We can close it. Thank you for your time, everyone, and see you. Bye-bye.
Thank you.
Okay, is this audible? Okay. Okay, just a quick note for everyone. The results for this hackathon, the results for this ACL competition will be announced along with the hackathon results in the afternoon, so stay tuned. Thank you.